Queueable Apex is Salesforce's modern solution for background processing. Before it existed, developers used future methods, but those come with real constraints that become problems the moment your job needs to work with anything beyond simple primitive data. In this session, we're going to build a complete picture of Queueable, what it is, how to write it, how to pass data into it, how to chain jobs, and how to test it correctly. By the end, you'll know exactly when to reach for it over future methods in batch. Future methods were Salesforce's original async tool. Annotate a static method with a future, call it, and it runs in the background. Simple, but there are three things you can't do. You can't pass sObjects or collections of sObjects, only primitives like strings and integers. You can't chain one future method to another, and there's no job ID returned. So once it's queued, you have no way to track whether it ran or what happened. These limitations are fine for simple cases, but they become painful fast once your background jobs need to handle real data. A queueable class has one requirement. Implement the queueable interface and define the execute method. The execute method takes one argument, a queueable context object, and that's where all your logic lives. Declare your class with implements queueable, write the execute method, and you're done. Everything else, instance variables, helper methods, constructor, is optional. This is why queueable is more flexible than future methods. It's an object, not just a static method. You can design it like any other Apex class, give it properties and behavior, and inject the data it needs from outside. To run a queueable job, call system.enqueueJob and pass a new instance of your class. That's the entire submission API. The return value is an Apex job ID, the same ID that appears in setup under Apex jobs. You can store this ID in a field, log it to a custom object, or use it to build a monitoring view. This is one of the most practical differences from future methods. With future, you fire and hope. With queueable, you get a ticket you can check. That alone makes debugging background pipelines much less painful in production. Because a queueable is a class, you design its constructor to accept whatever data the job needs. Here, update contacts job takes a list of contact records and a status string. Those values are stored as instance variables and used when execute runs. You can pass sObjects, lists of sObjects, maps, custom wrapper objects, anything. Compare that to a future method where your only option is a list of primitive IDs, forcing you to requery everything inside the method. The constructor pattern is cleaner, more explicit, and easier to test because the data dependency is declared up front. Chaining lets one queueable enqueue another from within its own execute method. Here, stage 1 job processes a batch of accounts and then enqueues stage 2 job to continue. This is the right mechanism for multi-step pipelines. Process what you can in one transaction, then hand off to the next stage. Pay close attention to the test.isRunningTest guard around the inner enqueue call. We'll cover exactly why that guard is required on the next slide, but remember, always include it whenever you chain from inside execute. Without it, your test will fail in a confusing way. In a test context, Salesforce allows only one queueable to be enqueued per test.startest and test.stoptest block. If you chain jobs and don't guard the inner enqueue, your test throws a governor limit error, not a logic error, so it's confusing to track down. The fix is one line. Wrap any chained enqueue in an if not test.isRunningTest. Check. This skips the chain during tests. To test the chain end to end, test each job class in isolation. This guard is not optional. You'll see it in every production queueable that chains. It's the first thing to add. Queueable context gives you the running job's ID from inside execute. Call ctx.getJobID, and you get back the same Apex job ID that was returned when the job was enqueued. Here we're using it to write a log record. Insert a job_log_c at the start with status running. Do the work, then update it to complete it. This gives you real-time visibility into your async pipeline, which jobs are in progress, how long they're taking, whether they succeeded. All from a SOQL query. If you're building anything that runs background jobs in production, this pattern is worth implementing from day one. If your queueable job needs to make HTTP callouts to external systems, add database that allows callouts to the class declaration alongside queueable. It's a marker interface, no methods to implement, just the declaration itself. Without it, any http.send call inside execute throws a callout exception at runtime. With it, callouts work exactly as they do in synchronous Apex, because the queueable runs in its own isolated transaction. The syntax is implements queueable database that allows callouts, comma separated, both on the same line. Add it whenever the job needs to talk to an external system via REST or SOAP. Asynchronous Apex runs with higher governor limits than synchronous code, the ones that matter most. SOQL queries go from 100 to 200 per transaction. CPU time increases from 10 seconds to 60 seconds. That's 6 times more processing time. Heap size doubles from 6 megabytes to 12. DML limits stay the same at 150 statements and 10,000 rows. In practice, the CPU time increase is what makes Queueable useful for compute-heavy jobs. If you're processing 100 records with complex logic and field transformations, synchronous Apex will hit the CPU wall where Queueable won't. Design accordingly. There's one limit specific to Queueable that doesn't apply to batch. In production, only 50 Queueable jobs can be queued in your org at any one time. If your code tries to enqueue a 51st job while 50 are queued, the enqueue call throws a limit exception. This matters if you're building systems that enqueue jobs in bulk. For example, 1 job per record in a trigger. If 100 records come in at once and you enqueue 100 jobs, 50 will succeed and 50 will fail. Plan your pipeline architecture around this limit. Either use batch for volume operations or implement a queue manager that controls enqueue rate. Salesforce gives you 3 async tools, and they're not interchangeable. Each has a specific job. Future methods are for simple fire-and-forget logic with primitive arguments. Queueable is for background jobs where you need complex state, job tracking, chaining, or callout capability. Batch is for mass data operations where you're processing thousands to millions of records. The mistake is reaching for whichever tool you learned first and stretching it to fit every case. Knowing when each tool is appropriate is what separates developers who write working code from those who write scalable code that holds up in production under real load. Use a future method when you need to make a callout from a trigger context. That's still its most common legitimate use case. Triggers can't call callouts directly because the transaction hasn't committed, but a future method can. Use future when the logic is genuinely simple. One method, primitive arguments, no chaining, no tracking. Future methods are not wrong. They're just limited. If those limits don't apply to your specific job, future is fine and simpler to write. The problems start when developers use future for jobs that outgrow those limits, and they've already built a pattern that's hard to migrate. Use Queueable when your background job needs to work with sObjects directly, passing them through the constructor rather than requerying by ID. Use it when you need a job ID for tracking or logging. Use it when you need to chain stages in a pipeline. Use it when the job needs to make callouts and you want explicit control over that behavior. As a practical rule of thumb, if you'd reach for a future method but realize it can't quite do what you need, missing sObject support, missing chaining, missing a return ID, Queueable is the answer. It's the modern default for background Apex jobs. Use batch Apex when you're processing large volumes of records, the kind where even 200 records per execute call is a reasonable chunk. Batch's start method returns a query locator that can iterate up to 50 million records, and Salesforce automatically divides that into execute calls of up to 200 records each. Queueable is not built for this volume. You'd need to chain hundreds of jobs to approximate what a single batch class handles natively. The rule is straightforward. If your operation touches tens to hundreds of records with complex logic, use Queueable. If it touches thousands or more, use batch. Testing a Queueable correctly requires test.startist and test.stoptist. Enqueue your job between those two calls, and when stoptist executes, Salesforce forces all queued async work to run synchronously, right there in the test transaction. After stoptist, your assertions run against the state the job left behind. This is the only reliable way to test async behavior in Apex. The test doesn't care that the job runs asynchronously in production. Startist and stoptist create a boundary that forces it to run inline. Set up test data in test setup, enqueue inside startist/stoptist, assert after stoptist. That's the complete pattern. The most common mistake when testing a Queueable is asserting before test.stoptist. At that point, the job is queued but not executed. Your assert runs against the pre-job state, and depending on what you're checking, it either passes incorrectly or fails with a message that doesn't point to the real problem. Always assert after stoptist, never before. The second mistake is skipping startist and stoptist altogether. Without those boundaries, the job is queued but never forced to run, and your test completes without the job having executed. Both mistakes produce tests that pass without actually verifying anything. enqueueJob is a complete real-world example. It implements both queueable and database that allows callouts, accepts a list of lead records through the constructor, loops through them, calls an external data provider for each email address, and updates the lead records with enriched data. The constructor stores the leads as an instance variable. The execute method iterates, makes a callout per lead, parses the JSON response, and collects records to update in a single DML call. A try-catch around the callout ensures one failed request doesn't abort the entire batch. Constructor state, callouts, and defensive error handling, all in one clean class. The pattern reduces to 3 steps. First, implement the queueable interface and write the execute method. Second, design your constructor to accept whatever data the job needs: sObjects, lists, maps, custom wrappers. Third, call system.enqueueJob with a new instance of your class. Everything else is additive. Database.allows callouts if you need callouts, ctx.getJobID if you need tracking, a chained enqueue if you need staging. Start with the 3-step skeleton, then add only what the job actually requires. That keeps the class focused, the logic testable, and the pipeline easy to extend without rewriting everything. Read the full Session 56 article on Real Syllabus at realsyllabus.com. It covers every concept from this tutorial with complete code examples. The interface, constructor pattern, chaining with the isRunning test guard, callouts, governor limits, and the full enqueueJob class. The comparison table for future versus queueable versus batch is in there too. Print it, bookmark it, use it as your decision reference. If you found this session useful, the Salesforce Developer Series continues every week. See you in Session 57.